Question 6. The value of x, y, and z respectively in the expression m to the power x, l to the power y, t to the power z for the universal gravitational constant g are A, we have the option, B, we have the option, C, and D also, we have the options. So what we're going to do in this case is very simple. So what they're asking us for this question is the dimension for universal gravitational constants. That's what they're asking us to do. So what we're going to do, we're going to go to the gravitational force, which is equal to G, equal to M1, M2 times what? Square of the distance between those masses. This is M2, and then we're going to make the G as a constant. We're going to make G as a constant, so we're going to have this over what? Over M1, M2 equal to what? Equal to universal gravitational constant. Since we've been told that G is constant, so we got an expression for that. So what we're going to do now, we need to get the dimension for this fraction. We need to get dimension for that fraction, and that will be equal to the force is m l t minus 2. The radius, the r, that will be l square over the m1 m2, that's mass, that's capital M, and then you square that square. So if you do the algebra, this is power 1, so that'll be m minus 1, okay, equal to what? Equal to, that's 1 minus 2, so we have m to power minus 1. This one and this one, that'll be L3, that'll be L to power 3, and then T minus 2. So that's the dimension for G, so which we are going to now write this G dimension, L3, T minus 2. We're going to equate that to a constant, okay, and that will be this constant, Ly, and then this one, okay, which they call the since we have dimension, we have the dimension for this equal to what? Equal to G, and we have an equation for that. G is a constant which has this formula, so we're going to have this one equal to the constant we have. So correspond the two equations together. You correspond them together by comparison this one to this one. The bases are the same, so the power will be equal to each other. This one to this one, y is equal to what? 3. This one to this one, z is equal to what? Minus 2. So that's minus 1, 3, minus 2. That's option B. That's option B for that question. Okay. Please, if you find these beneficiary, don't keep it to yourself. Begin to share the links of this channel, okay, by clicking on the watermarks on this video and subscribe. Please, for your questions, I promise to respond to your questions as fast as possible. Don't stop there. Share the links on all your platforms. Question 8, the dimensions of power are. So we have the options. So let's get the answer to that question. Power is work over time, rate of doing work or rate of energy. So, and work is what? Work is force times distance over time. Force is m l t minus 2. Distance is what? L, and time is what? Capital T. So let's do the algebra. So this will give us m l times l, that's l square. Then use indices for this one, okay, this is minus 2, this is power 1, so minus 2 minus 1, that's T minus 3. So that's the power, that's dimension of power, and that's option A. Okay, for the number 9, what is dimension of moment? Moment has this formula. Moment is force times perpendicular distance. Okay, force is dimension for force is m l t minus 2. Distance is l. So dimension is what? M l times l, that's l square, t minus 2. That's option B. And that's that on this question. Kindly smash the watermarks on the video and subscribe. click on like button and begin to type your comments. Make this section interactive. Thank you for doing that.